Hello everyone, this is Static and Dynamic Project presented by Group 1.
For introduction, static is the study of force acting between objects responsible for maintaining equilibrium, causing motion or changing shape. Daily activities like turning a doorknob or brush your teeth involve this force. Static is crucial in engineering fields such as mechanical, civil, aeronautical, and bioengineering. This concise introduction captures the essence of static, highlighting its significance in everyday life and engineering disciplines.
Hello, my name is Ahmad Farid Bizainuddin. My matrix number is CF230005. Today, I would like to talk about the structure that I choose, which is steel railway bridge that located at Lentong, Taman Johor Jaya. The material that used to build this structure is steel fastener, which is bolt and connector, expansion joint, and etc. Steel is provided the necessary strength to support heavy loads and withstand the stresses imposed by trains passing over the bridge. Fastener or bolt used to join components together and ensure they remain securely in place. Expansion joint used to accommodate thermal expansion and contraction of the bridge structure due to temperature change. They help prevent stress build-up and structural damage. So first, you can see the free body diagram that I sketched for the railway bridge. I assume that length of the bridge was 50 meter. So moment for the bridge, I get 3,927 kilonewton. So the each for the 1 meter the length of bridge, I get 78.64 kilonewton. 78.64 kilonewton multiplied by length of the bridge 50 meters, so I get 3,927 kilonewton. As you can see, I got submissional for moment is 1,963.5 kilonewton. For the reaction force at y-axis, at point A, I got 1963.5 kilonewton. Okay, for the center of gravity, total for area I got 7,000. For the area at x-axis I got 0, while for the area at y-axis I got 665,000. Center of gravity for the x-axis I got 0 millimeter, and for the y-axis I got 95 millimeter. For moment of inertia, as you can see that from the calculation that I get for moment of inertia from x-axis is 345,833.34 millimeter power of 4, and for the y-axis I got the same value from the x-axis. Okay, for the conclusion, from the calculation, we know that the bridge required pin support AY and AX and the roller support BY to resist force from the train and to hold the self-weight of the bridge. The load of the come from the AX contribute to support reaction from x-axis for the bridge is 0 Newton. The load that come from AX contribute to support reaction from y-axis for the bridge is AY equal to 16 1963.5 kilonewton. For the By, equal to 1963.5 kilonewton. The center of gravity of the I beam from the X axis is 0, and for the Y axis is 95 meter. Moment of inertia from the X axis is 3458333.34 millimeter power of 4. From the Y axis, we get the same value from the X axis.
Assalamualaikum. My name is Nura Atika binti Muhammad Noor, and for this project, I am appointed for beam structure. So, what is a beam? A beam is a member that can be comprised of a number of materials, including steel and wood, aluminium, to withstand loads. Typically applied laterally to the beam axis, beams can also be called members, elements, rafters, shafts, or purlins. A beam can exist within a frame, a truss, or on its own as its structure. For this project, the beam chosen is located at HEP Cafe UTHM, and it is made of cement, and the function of the beam is it is a fixed beam and are commonly used in continuous structures like multi-span bridges and large buildings. For this case, it is used to support the large buildings. Here is the free body diagram of the beam. The beam have a length of 5 meter and also a width of 0.5 meter. And since the beam is fixed on both ends, it becomes a simply supported beam with 150 kilonewton point load. The first thing that we need to find is the support reactions for the beam. The support used in the structure is fixed support, and since it is fixed on both ends, therefore the sum of force at x-axis is 0. For the sum of force at y-axis, we need to add on all the vertical components. We have the R, the reaction support at A, the reaction support at B, and also a 150 kilonewton point load that is pointing down. And assume clockwise to positive, we can use the sum of moment at A equal to 0. We use sum of moment at A equal to 0 to find the value for RAY and also the reaction at B. And we get the value for reaction for support reactions at y-axis on A and B with both having 75 kilonewton. Next, for the center of the beam, we first put the axis on the beam, and for this structure, I choose to put the axis on the end of the beam. And after calculating the area and also the total of area times with x and also with y, we can get the centroid of the beam with the coordinate of 2.5 for x-axis and 0.25 for y-axis. The last calculation is the calculation of moment of inertia. The first thing that we need to find is the inertia at x using the formula BH power of 3 over 12. We get 0.05, and then we need to find the dy value by subtracting the y to the y centroid. After that, we can calculate the a times the area times with dy power of 2, and we can get the moment of inertia at axis x, which is 0.05 meter power of 4. Doing the same for y-axis, and we get 5.21 meter power of 4 as moment of inertia for y-axis. For summary, this is the calculated value. The support reaction at vertical axis is 75 kilonewton for both ends of the beam, and support reaction is important to determine the structure's ability to withstand applied loads. The center of the beam is located at 2.5 on x-axis and 0.25 on y-axis, and we need to calculate centroid for accurate calculation of moments of inertia, which are used in structural analysis and design. For moment of inertia, we have 0.05 meter power of 4 on x-axis and 5.21 meter power 4 on y-axis. Moment of inertia need to be calculated in order to determine the resistance of a section to bending and torsional loads. And beam is important in structure because beam support the weight of a building floor, ceilings and roof, and to move the load to the framework of a vertical load bearing elements. And in order to withstand the combined weight of stack walls and transfer the support load, often larger and heavier beams called transfer beams are used in buildings
Assalamualaikum,
or
my name
industry.
is Zia Azmi bin Zadir Anwar. Today I'm going to talk about my structure, which is column and beam. So for column is a vertical structural element that primarily serves to support compressive loads. Columns are essential for maintaining the structural integrity and stability of a building. For a beam is a horizontal structural element that primarily serves to support and transfer loads applied perpendicular to its length. Beams are essential in maintaining the structural integrity and stability of a building. The material that used for the structure is concrete, which is located at Fellow's house at Taman Tun Dr. Ismail. This is my free body diagram. So the load that I put is 3 kilonewton per meter, the height is 5 meter and the length is 10 meter. So for the support reaction, each column have 15 kilonewton load. So my calculation for support reaction, the RB is 15 kilonewton, RA is 15 kilonewton. For my centroid, X is 3.2 meter, Y is 1.45 meter. For my moment of inertia x-axis, the I-axis is 1517.16 meter. For my moment of inertia y-axis, the total is 27.95 meter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Izzuddin, and I'm about to explain my structure, which is roof. Roof is an essential component of building's envelope. The roof is supported by the walls and sits atop the structure. Its main purpose is to protect the building from weather conditions such as wind, rain, snow, and sunlight. A roof design and materials are determined by building's architectural style and intended use. And also this structure roof of guardhouse at Perwira Residential College, THM. This is the Fibro-D diagram of a roof that I have drawn. The total length of the roof structure is 8 meters and its height is 6 meters. And the loads that have been applied at each point is 500. And this is my support ration calculation of the roof. So we get the RBY is equal to 1500 Newton force, and RAY is equal to also equal to 1500 Newton forces. And this is my calculation to get the centroid of the roof. So we get two different section of roof that we gonna use to calculate the roof at the center of the roof. So the first section we get the area is equal to 12 and the x is 1.33 and the y is 2, ax is 15.96, ay is 24. And for the section 2 we get the area is 12, the x is 5.33, y is 2, and ax is 63.96, ay is 24, and also the total area which is combined the two section that I have calculate is 24, and the total AX is 79.92, and total of AY is 48. So to calculate the X bar, just uh, the total of AX is divided by total of A. So uh, we're gonna get 3.33, and Y bar, uh, we have to divide total of AY with the total of A, or area. So we're gonna get 2 meters. So we are moving on with the moment of inertia of the roof. So we have two axis, which is x axis and y axis. Uh, for the x axis, we have two sections, which is section 1 and section 2. So for the area of the section 1 is 12, the ix is 24, and the dy is equal to 0. Uh, and ady square is equal to 0. And for the section 2, the area is 12, the x also 24, the dy also 0, and ady square also 0. So uh, the tot- so the total of ixx is that I have calculate is equal to 48. And for the y-axis, it also have to is divided to two sections. And the first section, we get the area is equal to 12. The ix is equal to 10.67. The dy is equal to 2, and the adx square is equal to 48. And for the section 2, we get the area is also equal to 12, and ix is also the same, which is 10.67, and the dy is also equal to 2, and the adx square is also the same, which is 48. And the total iyy that I have calculated is equal to 117.34.
Hi, Assalamualaikum. My name is Nasfa. Today I will explain about the building structure I choose for this project. Okay, behind me is a structure called cantilever slab. The material used to build cantilever slab is reinforcement concrete and steel. Reinforced concrete is the main material for cantilever slab. Concrete give a comprehensive strength, while steel reinforced give the tensile strength needed to handle the loads on the slab. Reinforcement steel is used as steel within the concrete to provide the extra structural support. These reinforcements help prevent cracking and keep the structure strong and stable. Okay, next, let's talk about the support system. The first is anchoring to the main structure, the cantilever slab. The cantilever slab must be securely attached to the main structure of the building, usually reinforced concrete columns or wall. To distribute the load safely, the anchors can be mechanical cast or cast integrally with the main structure. Next is steel reinforcement. The steel reinforcements within the slab must be extended and anchored into the main structure to make sure the slab stay in place, can bear the loads without a structural failure. Okay, that's all for this video. I will continue with the calculation on the slide. Hi, I'm back for the calculation. This is a free body diagram. I assume the mass of load is 40 kilonewton per meter. The length of beam is 4 meter. So I find the magnitude using 4 kilonewton over 4 meter times 4 meter equal to 160 kilonewton meter. Okay, next for separation. Okay, from the diagram, uh, uh, the axial force at point A is equal to 0 and Rex equal to 0. For external force at point A, axial force Fy equal to 0 and I do Ray minus 160 equal to 0. So I rearrange the calculation. Ray equal to 160 plus 0 equal to 160 kilonewton. So means Ray equal to 160 kilonewton. For moment at point A, I use the formula MA equal to F times D. So the from the diagram, the diameter is 2 meter. So I use the formula MA equal to F times D equal to 160 Newton times with 2 meters equal to 320 kilonewton. For centroid, I just divide the cantilever slab for two parts. For area, I find the area using a formula 2.25 times 10 equal to 22.5. For part 2, 3.45 times 4 equal to 13.x and sum of area is 36.3. For x, I just do 22.25 divide by 2 and get 1.125. For part 2 is 4 divided by 2 and plus with 2.25 equal to 4.25. For y, I just do like 10 divided by 2 equal to 5 and for part 2, 3.45 divide 2 plus 5 and get 6.725. For ax, I just time the 22.5 times 1.125 get the 25 for 25.31. For part 2, I just get 58.65 and the sum for AXL is 83.6 point 96. For AY, I just get it by 22.5 times with 5 and get 112.5. For part 2, I just times 13.x times 6.725 and get 92.805. The sum of what AY is 205.305. For therefore, x equal to sum ax over a. For y equal to sum ay over y. For x axis, ax sum ax 83.69 divided by 36.3 equal to 2.31 m. And for y axis, for y I divide 205 and 0.305 divide 36.3 and equal to 5.66 meter. Okay, next for moment of inertia for x axis. For area, I just take the old one to this and I use the formula Ix equal to BH3 divided by 12 So I just get for part one, I get the ix is the initial of x is 187.5. For part 2 is 13.69. For dy, I just I using formula y minus y. So for part 1, I get 0.66, and for part 2, negative 1.065. For a dy square, a dy square, I just use formula area times the dy square. So for part one, I get 9.801. For part two, I get 15.65. So from the table, I can get the sum of IXX. Uh, to find the sum of IXX, I use the formula IX plus ADY square plus IX plus ADY square to the end. So from that formula, I get the IXX. I get the 226.64. For Okay, for the next is y-axis. It's similar the area for from the past table. We use area for part one is 22.5, and for part two is 13.8. For IY, we use the formula is uh, b power of 3 h divided by 12. So using the formula for part 2, we get the IY is 9.49. For part 2 is 18.4. Okay, for the dx, we for find the dx, we use the formula dx equal to x minus x. Okay, from the table, you can see I get the dx for part 1, I get 1 for 1.185, and for part 2 is negative is 1.94. So for ADX, same like the previous table. So I get the ADX for part 1 is 31.60, and for part 2 is 51 point nine four. For some IYY, the formula is same like the past slides. So for some IYY, I get 111.43 is 0.43 meter power of 4. The conclusion, here we can make a conclusion that the cantilever slab is a type of reinforced concrete structure that is versatile and widely used. It also provides a clear span without intermediate support, which make it ideal for balcony, mezzanines, and stair. The use of reinforced concrete as the main material, then it is a combined with steel reinforcement. It provides the strength and stability needed to support heavy loads. Cantilever slabs are commonly used in modern construction due to their versatility, strength, and ability to provide open and flexible interior space. As we can see from the calculation of the body diagram, support reaction, central and moment of inertia above, which is an important aspect in the design of a structure because it involves determining the load and force that will be applied to the structure, and using that information to choose the material to use and suitable cantilever slab size.
Structural calculations are a critical part of any building project. They provide a detailed analysis of the building's design, ensuring that it can withstand various forces and stresses. Through the project, there are three things that need to be calculated, which are the support direction, center, and moment of inertia of the structure. All these calculations are essential in civil engineering as they are the first step for safe building. Throughout the calculations, we can do estimation and review the building structure before building it. The environment has a significant impact on various structures, and structural calculations plays an important role. Engineers use structural analysis to determine the effect of wind, earthquakes, and other environmental factors on the structure. By taking these factors into account, engineers can design structures that are more environmentally friendly and sustainable. Completing this project opened our eyes and provide a picture of what engineers do and how important the calculation in civil engineering.